Welcome to another wonderful edition of Comet Algebra. This video is for Algebra 2, Chapter 6, Section 7, Solving Polynomial Equations. Now please get used to reading the directions very, very carefully. When they say factor it, your answer should be factors in parentheses, like x plus 2 times 4x minus 8, stuff like that. But when they say solve, we want the answers now. So we're going to use our factoring skills. We're going to factor this polynomial, and then we're going to find the answers by setting these factors equal to 0. So we're told to factor this by grouping. So let's look and see if we can do that. Well, and sure enough, these two have a GCF, and these two have a GCF. So these both have an x squared in them, so let's factor that out, and then we have a 3x minus 1 left. And these two have a 9 as a common factor. So let's factor out a 9, and we get 3x minus 1. So we did get a GCF in these two, so let's pull that out. All right, so we've completed the factoring now. Now let's set these factors equal to 0 and find some answers. Solving this first one for x, we get x is equal to 1/3. Solving this one, first we subtract a 9 from both sides, and then when you square root both sides, you get plus minus the square root of negative 9, which is a perfect square, so we have plus minus 3i. So the third degree equation did give us three answers, 1/3 and plus minus 3i. All right, this statement is already very familiar to us. It comes from the fundamental theorem of algebra, and it just says whatever the degree is, that's how many roots you're looking for. And some of these roots are real, some are imaginary. For example, if you have a fourth degree equation, you're looking for 4 answers. All right, example 2, we're asked to solve this third degree equation. So first, let's take a minute and write this in general form. So we have x to the third minus 5x plus 2. Now this doesn't factor with grouping, so we're going to have to make a list of the possible roots, check them, and see if we can find some factors. So this time the possible roots aren't many, just the factors of 2, so we have to check plus minus 1 and plus minus 2. So let's plug these in and see if we can find any zeros. So when I plugged in 1, I didn't get a 0. Plugged in negative 1, that didn't work. But when I plug in a 2, I do indeed get 0. So I know that 2 is a root, and that means that x minus 2 is a factor. So let's use this root we found, and let's use synthetic to bring this third degree down to a second degree. And once again, you know you did your synthetic right, because when you get a 0 here, which has to happen when you have a root. So now we have one factor of x minus 2, and we have a quadratic of x squared plus 2x minus 1. And unfortunately, this doesn't factor nicely, so now we're kind of flipping back to our skills from last chapter. You learned all kinds of ways to solve quadratics. So your choice is here. Since it doesn't factor, you could complete the square on this, or you could use quadratic formula. I chose to use the quadratic formula this time, and when I simplify it down, I get negative 1 plus minus square root of 2. So now we have solved this. We have found all the roots. The first root we found was 2, and then the other two are negative 1 plus minus square root 2. So those are the answers. Example 3, we get to solve a bit of a higher degree equation. State the number of roots. Since this is a fourth degree equation, there are 4 roots for us to find. So we'll start by making a list of the possible rational roots. We know we're going to have to find 2 and use synthetic twice, so we got a lot of work to do. So the possibilities. First, we look at the factors of our constant, which are plus minus 1, plus minus 2, and plus minus 4. And our leading coefficient is 4, so we're going to be dividing these roots by the same list of factors. Dividing by 1 doesn't change them, but when we divide each of these by 2, it does add some. It adds a 1/2, but 2 divided by 2 is 1. We already have that. 4 divided by 2 is 2, and we already have that. So now we have to divide all of them by 4, so that adds a plus minus 1/4, and I think that's our complete list. So now we're going to use the factor theorem here and start plugging in and see if we can find one of these to give us a 0. So I tried 1 and -1 and they didn't work. But when I plug in a 2, now I get a 0. When I was in school, we didn't use the factor theorem too much. We would do synthetic on all of these, and if some of you find that easier, you could just go ahead and do synthetic with these roots and look for a remainder of 0. It's the same thing. So now we know that 2 is a root. We can actually put that up here as one of our answers. And then we use synthetic with the 2 to bring this 4th degree down to a 3rd degree. So now we have our 3rd degree, but we know we have to find another root to bring it down to a 2nd degree. So sometimes it can be beneficial to, in fact it usually is, to look at this now and make a new list of possibilities. A lot of times this list is shorter. And then we need to look in that list for another root. So this list of factors is plus minus 1, plus minus 2, and then if we divide those by the factors of 4, it just adds a couple. I guess it's pretty much the same as our other list, but please keep in mind we need to start over with these because sometimes there's a double root and we can miss it or something like that. You can just go ahead and eliminate the 1s because if they weren't a factor of the first equation, they're not going to be a factor of this one. But we do have to try the 2s again. So I'm just guessing here. Let's try f of 2 and then plug that in. And sure enough, we do get 0. So we have this 2 is another root. And since it was a root the first time, I'm going to put it in my list here. It's actually a double root. So we're going to use 2 now in our synthetic. We're going to do synthetic again on this 3rd degree equation to bring it down to a 2nd degree equation. So now our quadratic, finally we get down to the 2nd degree. We have 4x squared minus 1. And hopefully you recognize that this is the difference of two perfect squares, and it does factor very nicely into 2x plus 1 and 2x minus 1. And now I can set these factors equal to 0 and get my final 2 answers. This factor gives me an answer of -1/2, and this gives me an answer of +1/2. So now finally I do have all the roots of this equation. I have 2 twice, it's a double root. You don't need to list it twice, but I just did for this example. And then we have plus minus 1/2. So on a test, if you just wrote 2 plus minus 1/2, that is a complete list of the answers. All right, these next 2 theorems are very, very easy. The conjugate root theorem says, well, if you have a conjugate like 4 plus square root 7, and if that is a root of your polynomial, well, then its conjugate of 4 minus square root 7 is also a root. And this is just something that is assumed that you know, that conjugates go together. If one is a root, so is the other one. Same with complex numbers. If 3 plus 2i is a root, well, then 3 minus 2i is also a root. Conjugates, they go together. So 2 very simple theorems. It is assumed that you know this, so please just click save on that. Example 4 is just a little bit of practice on this. Given that the following are roots of a polynomial, state the other known roots. Well, if 4 minus 3i is a root, so is 4 plus 3i. If a positive square root 7 is a root, so is the negative of that. And if 3 plus square root 5 is a root, so is 3 minus square root 5. Here's how you'll use that knowledge. they will give you some of the zeros, and they'll want you to go backwards now and write the big polynomial function that has these as zeros. Now if 2 is a zero, we know that x minus 2 is a factor. And they're only going to give you one of these. They're assuming that you know that the conjugate is also included. So we do have 3 zeros. So we need to set up 3 factors, which is a bit of a pain. The x minus 2 is not too bad, but now we have x minus that first factor of x plus 5 square root 3, and we have x minus the conjugate that we knew was also a root of x minus 5 square root 3. So I need you to take a look at these three factors here before we start simplifying, and we got to multiply this whole mess out to come up with the polynomial. So let's start by distributing these negative signs, and the strategy we're going to use is we're going to multiply these last 2 factors first, and then we'll take care of this x minus 2 at the end. So like I said, let's distribute the negative sign here. So I have x minus 1 minus 5 square root 3 and x minus 1 plus 5 square root 3. So now let's multiply the trinomial times the trinomial, and like I said, we're going to wait with this one till the end. So we have 9 multiplies to do. So make sure I do this right. So the first thing I did was multiply this x times all 3 things in the second trinomial. And now I'm going to take this negative 1 and multiply it times all 3 things. So when I multiplied the negative 1, I got negative x plus 1 and then minus 5 square root 3. So the last thing now is to multiply this negative 5 square root 3 times everything in the second trinomial. So check and make sure you agree with the multiplication and the last part. And now because conjugates were involved, we know there's going to be a lot of things that subtract away. I'm just going to put this x minus 2 back in front here so I don't forget about it. And then what we have left here, and I'm going to kind of cross it off as I use it. We have our x squared, and then we have a minus x, and a minus x is a minus 2x. The 5x square root 3 is positive here and negative here, so those subtract away. And the negative 5 square root 3 subtracts with the positive 5 square root 3. So I have a plus 1 and a minus 75, which gives me a negative 74. So we're almost there. The last step is to multiply this x by everything, and then the negative 2 by everything. So first multiplying the x, I get x to the third minus 2x squared minus 74x. Now let's multiply this negative 2 times everything. I get negative 2x squared plus 4x plus 148. So now just combining like terms, we end up with x to the third minus 4x squared plus 70x plus 148. So this is the polynomial that had those 3 things that we were given as zeros, as answers. All right, so now you have everything you need for section 7, so have fun with math.